Welcome you all to the GIS Hub YouTube channel. This is our third video of the lecture series related to the fundamentals of remote sensing. And today's video is about interaction between matter and electromagnetic radiation. So without wasting much time, let's move into the video. It is obvious that all the matter in Earth's surface emits, absorbs, reflects electromagnetic radiation. For an example, if we consider why a leaf looks green color is that there is a chemical called chlorophyll and it absorbs blue and red spectra and reflects green spectrum. That's how leaf gets its green color. In other words, the way of interaction of electromagnetic radiation with the objects are different from object to object. So these unique characteristics of matter called spectral characteristics. So if we further discuss about spectral characteristics of objects, we have to know about spectral signatures as well as reflected energy. With the technological advancement, special sensors have developed to measure or capture electromagnetic radiation or electromagnetic energy which is reflect, absorb or emit from objects. From that, we can identify features on the Earth's surface. So as an example, if we consider about reflected energy, the amount of energy reflected from the surfaces is expressed as the percentage energy striking the object. If the sensor records 100% reflectance, which means all the striking light bounces off from the object. Or if the sensor records 0% reflectance, none of the striking light returns from the surface, which is all the light is absorbed by the object. So practically, reflectance values of the objects lies between those two extremes. When the percentage reflectance values of objects are plotted against the different kind of wavelengths, those plots can be known as spectral signature curves. These signatures help to classify remotely sensed images to different landscape features such as water, vegetation, and soil, etc. Or in other words, the electromagnetic radiation behaves differently depending upon the material. As for instance, the water reflects very little electromagnetic radiation, while soil and vegetation reflect electromagnetic radiation under different wavelengths such as visible, near-infrared as well as mid-infrared. We can use these properties to help differentiate between various elements. Actually, why an object have a particular characteristics of reflection, absorption or emission? In order to answer that question, one has to study the relationship between the molecular, atomic and electromagnetic radiation. So in this video, hereafter, I will briefly explain the interaction between hydrogen atom and absorption of electromagnetic radiation for your simplification of the study. Interaction between hydrogen atom and absorption of electromagnetic radiation. The figure in the left side of the screen shows an hydrogen atom and it has a nucleus as well as an electron, and the circles denoted the electron orbits. The E1 is respect to the inner circle energy level as well as E2 represent the outer circle energy level. The inner state of an hydrogen atom depends on the inherent and discrete energy level. The electron's orbit is determined by the energy level. If electromagnetic radiation is incident on an atom of hydrogen with a low energy level, which is E1, a part of the energy is absorbed and an electron is induced by excitation to rise to the energy level E2, resulting in the upper orbit. The electromagnetic energy, which is E, is given as in the right side figure. E equals hc divided by lambda. Here h is the Planck constant, c is the velocity of light, and lambda is the wavelength. The difference of the energy levels can be denoted as delta E, which is equals to E2 minus E1, which is absorbed. In other words, the changes of the inner state in an hydrogen atom is only realized when electromagnetic radiation at the peculiar wavelength, which is lambda h, is absorbed in an hydrogen atom. Conversely, electromagnetic radiation at the wavelength lambda h is radiated from an hydrogen atom when the energy level changes from E2 to E1. So from what we learned up to now is all matter is composed of atoms and molecules with a particular composition. Therefore, matter will emit or absorb electromagnetic radiation at a particular wavelength with respect to the inner state. In this table, different types of inert states are classified and their associated electromagnetic wave is listed below. As an example, gamma rays are radiated in a nuclear transmission and in disintegrations. The ultraviolet rays are radiated the ionization by outer electron removal. Where the visible light is radiated when excitation of valence electron as well as infrared rays are radiated in a molecular vibration or a lattice vibration situation. So up to now from this video we have already learned about the spectral characteristics as well as why does an object have a particular characteristics of reflection, absorption or emission. So in future videos we will be discussing about further fundamentals of remote sensing factors, and thank you for watching the video, and if you like the content please hit the subscribe button and click the bell icon too, then you can receive videos as soon as I publish them. So thank you very much, see you soon.